download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about separating metals. Now, last video we looked at the reactivity series, so let's just very quickly recap the reactivity series. At the top we have potassium, and then sodium, lithium, calcium, then magnesium. Now potassium, sodium, lithium and calcium we really describe as being very reactive. And magnesium into carbon, now it's important why we've added carbon into that and you'll see why in later. Zinc and iron are described really as being fairly reactive. And then hydrogen and copper are really described as being not very reactive. So as we can see really from here, at the top we have our most reactive, and as we go down they get less and less reactive until the bottom where we have the least reactive. This is the reactivity series. Now, most metals are found as ores, and I'll talk about that in a second, but we need metals for all sorts of uses. Metals are very, very important in our lives, and we really need them. So from electrical wiring to use in construction, metals are incredibly important. And as I just said, most metals aren't just found in the earth as the metal, they are found as something called an ore. Now, an ore is a rock. Okay, and it has quite a strict definition. A rock that contains enough of a metal compound in it to be worth extracting. Now, this point here about it being worth it is a really, really important part of that definition. We may come across a rock that only contains a small amount, let's say 0.5% of the metal that we actually want, and therefore it will cost more to extract it than that metal is actually worth. Okay, and if that's the case, then we don't consider it an ore, because we will not extract that metal because it's not worth it to do so. However, if we find a rock that contains lots of metal, and we will make more profit from the metal than we do from extracting it, then it is worth it, and therefore we consider that rock to be an ore. Okay, and now most metals are actually found in the form of an oxide, so they're metal oxides. So for example, iron could be found as iron oxide, and we really need to be able to extract this from the ore. Okay, and this is what we consider the ore, the oxide. Okay. But it's really, really important to note that it's only considered an ore if it contains enough of a metal compound to be worth extracting. Some elements are actually not found within ores. So we said really here that most elements are found as ores. Some elements are not found in as ores and are actually so unreactive that they can be found as elements of their own in the Earth's crust. So for example, we look at gold. Now gold is incredibly unreactive, and because of that it won't have reacted with oxygen to form an oxide, and it will just be present in the Earth's crust. Okay, so some elements are not found as ores because they're so unreactive. For example, we have gold. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, the way we extract the metal from its ore and from its metal oxide very much depends on its reactivity. And this is why I started talking about the reactivity series at the start of this video. Elements that are more reactive than carbon, so these elements here, we can extract it using something called electrolysis. Okay, and we will come across electrolysis and I'll talk about it in future videos. But for elements that are more reactive than carbon, we extract it from their ore using electrolysis. However, electrolysis is very, very expensive, and therefore if we don't have to use it, we won't use it. And for the elements that are less reactive than carbon, we don't need to use electrolysis, because what we can do is we can do a reduction reaction, okay, with carbon. And what that means is carbon will displace the metal from their ore. Okay, this is because carbon can only take the oxygen away from metals which are less reactive than the carbon itself. So let's do an example. Okay, so if we have a metal oxide and that metal is less reactive than carbon, if we add it to carbon, we are going to produce the metal. The metal is going to be extracted on its own, and also carbon dioxide, because the carbon is going to react and take the oxygen from the metal if it's more reactive. Okay, so let's go through an example, and we'll take iron for example. Now iron is less reactive than carbon, and therefore carbon can displace iron from its oxide. So iron oxide plus carbon in a blast furnace will make iron, and therefore we've got what we want. We want our iron on its own. We've got that, plus carbon dioxide. So because carbon is more reactive than iron, it will take the place of the iron and bond with the oxygen itself to form carbon dioxide. If we go through one more example, zinc oxide plus carbon will make zinc, which is the metal on its own, is what we want, plus carbon dioxide. So again, the carbon is more reactive than the zinc, and therefore it will take the place of the zinc and react with the oxygen. This doesn't work, however, as I just said, for elements that are more reactive than carbon. So for example, if we try to do calcium plus carbon, that would just leave, calcium oxide plus carbon, we'd still get calcium oxide plus carbon. Because calcium is more reactive than carbon, carbon cannot take the place of the calcium with the oxygen, so it does not change the reaction. Okay, so just be aware, just remember that for elements that are less reactive than carbon, we can use reduction with carbon. For elements that are more reactive, we can extract them using electrolysis, and we'll talk about that in the next video. And the general word equation for a reduction reaction with carbon is the metal oxide plus carbon produces the metal on its own, but only if it's less reactive than carbon, plus carbon dioxide. So what I'd now like you to do is try and have a go at these questions to really check your understanding on this topic, and we'll go through the answers together. So pause the video now. Okay, question 1. A scientist finds a rock with a very small amount of aluminium oxide in it. Explain why the rock cannot be called an ore. Okay, because if it's got a small amount of aluminium oxide, it is therefore not worth it to extract, and therefore it is not an ore. Okay, remember, really we described as ore as something that it's worth extracting from the ore, i.e. it's going to cost less to extract it than the metal is actually worth itself. If we find a small amount, then that's not going to be the case, so it's not worth it to extract, and therefore it cannot be considered an ore. Francium is more reactive than lithium. How can francium be extracted from francium oxide? Well, lithium is extracted using electrolysis. It cannot be reduced by carbon, and therefore you would assume that francium oxide could also be extracted using electrolysis. Aluminium is more reactive than zinc, but less reactive than magnesium. What more information would you need before you could say how aluminium should be extracted? Well, if we zoom into our reactivity series, it goes magnesium, then it goes carbon, then it goes zinc. So we've got here aluminium, and we're saying it's more reactive than zinc, so it's going to go above zinc, but it's less reactive than magnesium, so it's going to go below magnesium. So really we need to now find out whether it's more or less reactive than carbon. So whether more or less reactive than carbon. Okay, so it's either going to be here or here. So we need extra information. We need to find out whether it's more or less reactive than carbon. Lithium, iron and zinc are all placed in an acid. Which one would react the most, and explain your answer? Well, that would be lithium. And that would be because it's more reactive. So lithium, because it's more reactive, it's higher on the reactivity series. And finally, zinc can be produced from zinc oxide by reduction with carbon. Write a word equation for this reaction. So we have zinc oxide plus carbon, and we know this produces the metal, so zinc plus carbon dioxide. So that should have been what you had written for that. So we've now looked at how we separate metals. We've very briefly had a recap of the reactivity series, and then how we can apply that to reacting and extracting metals. For metals that are more reactive than carbon, we use electrolysis, and for ones that are less, we use reduction using carbon. You can now move on to the quiz and the exam questions to really test your knowledge. If you need any help or you didn't understand anything in the video, then please do get into contact with one of our tutors who would be happy to help.